Okay, welcome. This is the week 4 webinar for the statistics class. And let me tell you the plan today. So what we're going to be doing is, as always, always happy to answer any questions that you might have. If you just ask, I'll do my best to answer. And then we're moving on to pretty much the topic that is going to be used for the rest of the entire course. And we really won't quite get the reason why it's so important until next week. So this is where you just got to trust me that this is actually a really important topic, and that is the normal distribution. And we'll start out with the standard normal distribution, which is kind of like the easiest example. But won't necessarily be easy to everyone, but honestly, my guess is this might be the easiest week of the entire class. So if you're bored, I apologize, but it's a pretty light week, but important. You need to really understand what's going on, but it's easy. And we will talk about how do you calculate probabilities and how do you calculate percentiles. So if you remember last week, we looked at how to calculate probabilities and percentiles, not when we had a normal distribution, but in particular when we had a uniform distribution. And the nice thing about that is that it was just a rectangle, and you just do base times height, and you multiply the two numbers, and you're done. It turns out the normal distribution, the calculations are brutal. Why is that really good for all of you? The ideas? Why is it really good that the calculations are brutal for you all? Don't see y'all jumping in. Okay, the reason is that the calculations are even hard, but brutal for sure, is you just let the calculator do it and you don't have to worry about anything behind the scenes. You just hit calculate and it just gives it to you. So that's the good news. But I will let you know the behind the scenes is really brutal. But you don't have to worry about behind the scenes. Any of you know calculus? Okay, my guess is not. Usually not in this class, but you never know. But you have to know not just calculus, but a lot of calculus. And we're not doing any of it. You just have to trust me. It's trust me that when I did the calculator and I coded it all up, it all works, and it does. We'll look at next the general normal distribution, which is really what's used. It's really what's used. The point of the standard normal distribution is to get you set up so that you can kind of see what's going on. And then the general normal distribution is what's really going to be used, and we're using it. And we'll also do calculating probabilities and percentiles with the general normal distribution. Again, it'd be brutal if you had to do it by hand, but you don't. It's all done on the calculator. So that's the good news. And I'll give you some applications. I will give you some applications which are nice. It turns out, though, the real applications for the normal distribution occur next week. So the big applications occur next week, and then for the rest of the entire course, the big applications are going to occur. So, but next week, there's no suppose it's normal. Next week, it's going to be normal, because in most cases for surveys, you get normal distribution. So that is the plan. I do want to remind you, this is week 4. Why is the number 4 important?
There's an exam.
Yep, 4 is an even number. 4 is an even number, and it's important to remember that any even number week, you have your exam. So make sure that you prepare for the exam. Don't wait till the last minute. That's when you can get sick or the internet can go down. And I only give extensions if you tell me by Friday. So there's no reason to wait until Sunday night to start taking it. But what you should do is you should first do the chapter 6 assignment, and you should do the discussion post assignment, and then go ahead and do your exam. That's my recommendation. Because the exam does cover chapter 6 in a pretty big way. So, don't just assume you know 1 through 5, so you're good. You also have to know chapter 6. And in terms of how the exam is going to work, it's more than half will be the newest stuff, which is chapters 4, 5, and 6. But then there will be a chunk that is chapters 1, 2, and 3. And that's kind of how all the exams are going to work, is that there's going to be a larger percent that covers the newest stuff that you hadn't been examined on, and a smaller percent, but not no percent, on the older stuff. So you can't forget anything from the class throughout the class is the idea. But the newest stuff is the where the bigger points are. So, and in terms of the exam, it's basically the same idea. Get online, you have 90 minutes, and then you work on your exam, hit submit, and you're done. Okay, and the problems will be literally, they are randomized. Almost all of them are directly randomized from the homework randomizations. So you're going to see the same problems with different numbers sometimes. Some you won't see the same problem because when you did the homework, your randomized question wasn't the same as the randomized question on the exam. Sometimes it will be. Okay, numbers are almost always different because they're random numbers, or like there's so many different choices. And then there are a few written problems at the end, and make sure you do the written problems. And I want to remind you that when I go over this webinar, that make sure if I tell you have to have certain vocabulary, you have to have that vocabulary, or I take off points. Same was true on your discussion posts. If you didn't have all the vocabulary last week on discussion post reply, then I took off points. And remember, that was many, then it was likely, we had average, we had close to, do you remember all those words? They had to be there, and if they weren't, I took off points on your discussion post assignment. So same thing is that I have to pay attention to the webinars, and anytime I tell you the words have to be there, they really do. And I will take off points. So the exam is coming, so you definitely want to work on that. The other thing that you want to work on, and you still have a little bit of time left, but not that much, is Project One. So if you haven't posted your Project One idea yet with your group, then post it on the Project One discussion board, and I will always, let you know if it's going to work, or more often than not, I'll let you know adjustments that should be made to make it better. And then after that, that's when you go and you collect your data. You conduct your survey. Okay, so in terms of timeline, I strongly recommend by in the next couple days, you have your project idea and you have posted it, and I've helped you out with it, and you've got it. So that maybe at the end of the week, you can have your data done, because that's the idea. So timeline is real important. Any questions about anything? Any questions? Again, this is a webinar. I'm always happy to answer questions. This is your chance. Okay. There's one other thing that probably doesn't mean anything to any of you, but my office is now A218 instead of A210. The weird thing is my office has not moved. Any guess what happened?
There was a new office built.
Yeah, there's a whole set of new offices on the other side of this hallway, and they wanted to redo the numbering system. So I'm in the exact same spot I've been for 20, my 28th year, but my number has changed. So it's A218 if you ever come to my office physically. But again, that's for most of you, you're not even in Tahoe. But if you happen to come to my office physically, it's A218. I put that on the syllabus also. So that's there, but I figure I should mention it since it's now officially changed. It's kind of weird. I don't get to choose those things. So that's just a note. Okay, if there's no questions, let's get into standard normal distribution. And I've kind of hinted on the normal distribution a little bit in terms of the shape. Anyone remember what the shape of the normal distribution is? Maybe in a word?
Bell curve?
Yeah, it's a bell curve. Okay, so it is kind of bell-shaped. Okay, and what we're going to call it is the normal distribution. The standard normal distribution is going to have mean 0 right in the center and standard deviation 1. Okay. Unlike the uniform distribution, where if you wanted to find area, you just take base times height. Here, if you wanted to find area between, say, -1 and 0, good luck finding that area. Doing it by hand. Not going to happen. Okay, so that's what I meant is it is brutal. Okay, so I'm going to say it really fast. If I say it really fast, that means you shouldn't even listen to me unless you really love mathematics. And that is, if you want to find out the area between -1, you would find 1 over the square root of 2 pi times the integral from -1 to 0 of e to the negative x squared over 2 dx. So that would be how you do that. And that'd be very brutal using something called power series, but we're not going to do any of that. Okay. Instead, what we're going to do is the first thing is we're going to have the empirical rule. Okay. And the empirical rule has already been mentioned, but now we actually can really get into it because we have this beautiful picture of the normal distribution. And what the empirical rule says is that the probability of being between -1 and 1 is about 68%. Okay. So that's the majority, by the way. Majority is over 50%, and 68% is definitely over 50%. So most of the data has a -1 and 1 as your interval. Okay. And if you want the probability of being between -2 and 2, then that's going to be 95% or 0.95 if you want to write it as a probability. Okay. And then the third one's a little messier, but that is if you're between -3 and 3, then 99.7% of the data will go between -3 and 3. And that is the standard normal distribution. And again, standard means standard deviation is 1, the mean is 0. Notice some very important things about the normal distribution. One is it's unimodal. Do you remember what unimodal means? That was one of those stats words. Remember what unimodal is? Yeah, single hump. Okay, single hump is a good way of saying it. So there's one high point. Okay, it's also symmetric. It's also symmetric. And that means that if you put a line, if you take a mirror at this vertical line from 0, then the left-hand side is the mirror image of the right-hand side. So it just flips across. So it's perfectly symmetric. Okay, so that's really important. It's unimodal and symmetric. I'm going to be using that, especially the symmetric piece. Another couple things is that it goes forever. Remember, the uniform distribution was like between 5 and 7, and that means below 5, it never happens. Above 7, it never happens. The normal distribution never hits 0. Okay, I know it looks real close. It gets really close to 0, especially after you get to 3 or before you get to -3, but it never actually touches the x-axis. So it goes forever. Of these three, 68, 95, and 99.7, let's see if you can guess. It's just total guess, by the way, unless you've had statistics. Which of the three is most important? What's your guess? Okay, I see you guessing 68, but you guessed wrong. 95% is the most important. 95% is most important. Usually the reason for that is people are okay, usually okay if 5% of the time they make a mistake or get something wrong. And that's kind of how this 95% works, is that most of the time, very good amount of time, you are within 2 standard deviations of the mean, or between -2 and 2 for the standard normal distribution. So that's kind of the area that you want, that's like common enough that you feel comfortable making a decision based on it. Okay. You could say 99.7, but that's only if there's some disaster that happens if you get it wrong. Because then you want to, really, really small chance of being wrong. 68%, that you'd be wrong a lot, and nobody wants to be wrong that often. That's kind of the idea. So in the world, that 95% is the most important, and that's between -2 and 2. Okay. So let's do the first question. Find the probability that z is between -1 and 1. And I want to mention the way you write down that we have a standard normal distribution. We have z, then we hit this little tilde. We saw that for the uniform distribution, but it also works for the normal. And then you use n for normal. And then 0 because that's the mean, and 1 because that's the standard deviation. So that's the notation to say that the variable satisfies the normal distribution with mean 0, standard deviation 1. Very important to understand that. Okay, so what is the probability that z is between -1 and 1? See if you can tell me. And the hint is it shouldn't be hard at all. Yeah. So again, we have this empirical rule that says 68% is the chance of being between -1 and 1, but for probabilities, you always turn it into a decimal. So 68% as a decimal is 0.68. Any questions? Any questions on this very easy example? Okay, let's do some more examples. We're going to have lots of examples, by the way. Find the probability that z is less than 3. So here's 3. We want the probability that z is less than 3. That one's a bit harder. Any suggestions on a plan on how you might think about it? Any thoughts? And again, we know that between -1 and 1, it's 68%, -2 and 2 is 95%, and -3 to 3 is 99.7%. So what's the probability that we're less than 3, which is all of that? Everything to the left of 3. Any thoughts on how we might do that? This one actually takes a little bit of work. Nothing too brutal, but it takes some thinking. Okay, so one thing that you might want to do is say, well, what do we know? There's that number 3, and there's something we know about the number 3. What do we know about when we saw a 3 for probability? Start with how many numbers are less than 3. It's not how many numbers, it's an area under the curve, which you're not going to be able to do. The math is too hard. Okay, so let me tell you what we can do. We don't know all the way less than 3, but we know -3 to 3. So let's start there. So that's going to be the probability that -3 is less than z is less than 3. But the problem is that's not all of it. What did I miss? I want the probability are less than 3, and I know how to go from -3 to 3, but what did I miss? Yeah, for example, -4 or -3.2 or -3.9 or -5.6. Anything that is to the left of -3, I've left out. So I need to put that back in. So that's plus the probability that z is less than -3. Just a note, because we have a continuous distribution, you don't have to even think about whether you need a less than or a less than or equal to. It makes no difference because that equal to part always has probability 0, so you're not missing anything. So just a note, if you're wondering, if you put those together, you're missing the -3, but it's not a problem. All right, well, let's work this out. What's the probability that z is between -3 and 3? Let's do that first piece. That's the easy one. What is that probability that we're between -3 and 3? Using the empirical rule. Yeah, so that's going to be 0.997. Okay, now what we don't know yet is what about the probability that we're less than -3? That's going to take a little bit of thinking. So this is where being symmetric is important. If I wanted the probability of being either on this left tail or the right tail, that's going to be the complement of being between -3 and 3. Do you remember how to find a probability of a complement? There's something called a rule of complements. Remember how that works? Yeah, it's 1 minus. So I'm going to put a parenthesis here. I'm going to write 1 minus the probability that it's between -3 and 3. That's 0.997. But the problem with that is that's the complement, and that's the left side and the right side. But here's the good news. We have symmetry. This graph is a symmetric graph. So the right-hand side and the left-hand side have the same probabilities. So if I know they have the same probabilities, and I've given both sides, and I only want the left side, what do I have to do? I'm given both sides, but I just want one of the sides, and I have symmetry, but what can I do to find just the left side? Yeah, I divide by 2. Right? I divide by 2 because the left and the right are the same. So that means the left plus the right is the same as 2 lefts. So 1 left is half of the left plus the right. So then I'm going to take 1 minus 0.997 and then divide by 2. Any questions on that? What I can do, I can just copy that guy, put it into Google, and it goes 0.9985. One nice thing about Google, it just knows that I wanted a calculator. So let me stop. Are there any questions about how I found the probability that z is less than 3? We'll have a little basic geometry here. Okay, if there are no questions, let's do part C. Find the probability that z is between -1 and 2. So what is the probability that -1 is less than z is less than 2? So that's going to go from -1 to 2. It's this stuff. Okay. So what do I know? Kind of going to be similar, but not exactly the same as the last example. What can I use this time? I want this between -1 and 2 area. Any thoughts? Okay, I can say -2 to 2. And by the way, there's two ways of thinking about this, and that's one of them. I'll go with the way you suggested. And that's going to be the probability that -2 is less than z is less than 2. But that would be too much because that's all of this, and I don't want this part. Do you see that? So what I need to do is I need to subtract the probability that that z is in this area that I don't want, the -2 to -1 area. So that's -2 is less than z is less than -1. Any questions so far? All right, the first piece should be easy. What's the probability that z is between -2 and 2? That's the easy one from the empirical rule. Yeah, 0.95. Any questions on that? And then get a minus, and now I need the probability that we're between -2 and -1. And I'm going to do kind of like what I did before, is instead of just doing this piece, let's look at this piece and 1 to 2, kind of the other side of the mirror. If you take those two pieces together, that's going to be all the stuff between -2 and 2 minus the stuff between -1 and 1. Any questions on that? And to find that, all the stuff between -2 and 2 is 0.95. And then minus the stuff between -1 and 1, and that's going to be 0.68. But the problem is I got this piece and I got this piece, and I only want the left piece. What can I do? What should I do for it? Yeah, divide by 2. Any questions so far? Okay, and then I just use calculator. And it gives me 0.815. Any questions on this idea? Easy enough? All right. Let's do the next example. Okay, remember when we had the uniform distribution examples? There were two types. One type was that you were given the base and you wanted to find out the area. So you want to find the probability that x is like between two numbers or something like that. And you wanted to find out the area. And the other type is when you're given the probability and you want to find the value of x so that the probability of it being greater than or maybe less than that value of x will be what you're given. Same idea for the normal distribution. Sometimes you are given the values, in this case we're calling it z for the standard normal distribution, and you want to find out the probability of being between those values. But then there's other times when you're given the probability and you want to get back to z. So let's see what we got. Find the value of z such that there is a 2.5% probability of being greater than this value. Any questions on this idea? Okay, so the idea is there's going to be some value where if you look at the area to the right, because greater than is to the right, that'll be 0.025. Okay, or 2.5%. So here's the trick. And this is, we've already done something very similar. And that is, if you only have one side, that's not enough to be able to use the empirical rule. We need both sides. So if there is, let's make this bigger. Oops. One more try. Make it bigger. If there is a 2.5% chance of being on the right of that value, then there is a, well, we can go 2.5% plus 2.5% chance of being on the right of that value, or on the left of negative that value. Anyone lost on what I just said? That's that symmetry piece. If the left is 2.5%, then the left and the right will be 5%. And when I say the right of negative the value, gotta flip it over to the negative side. Any questions so far? Okay, what's 2.5% plus 2.5%? Hopefully you can do that. Probably without a calculator. Yeah. So I'm actually going to put this here equals 5%. Okay, if there's 5% chance of being on these outsides, what's the percent chance of being inside? If there's 5% chance of being outside, what's the percent chance of being inside? Yeah, 95%, because 100% minus 5% is 95%. So there's a 95% chance of being in between negative that value and that value. Why is that good? So why is that good? Why can we just answer the question now? Hint is, look at the empirical rule of the picture. What's that picture tell you? About 95%. Yeah, 95% is between -2 and 2. Okay. Now, we're saying there's a 2.5% chance of being on the right. So it wouldn't be -2 because that'd be a huge chance of being on the right. It's going to be 2. Therefore, the value of z such that there is a 2.5% probability of being greater than this value is z equals 2. Any questions on this reasoning? Questions? A lot of logic involved. I was just like looking at the picture and kind of putting pieces together. Okay, there's not a lot of hard math. It's just putting pieces together, or not hard like arithmetic math stuff. We will get there. Okay, find the 16th percentile. Okay, I'm going to do this one a little faster because this one is very similar. If I want the 16th percentile, that means the probability of being less than this special 16th percentile, call that Z, is 0.16. Okay. By the way, if the probability of being less than a number is 0.16, are we on the far left or far right? Which side are we on? Are we on left or right? If the probability of being less than the value is 0.16, are we on the left side or the right side? Yeah, we're on the left side because we have a small probability of being less than that, which means we'd have to be on the left side, because if we were on the right side, there'd be a large probability of being less than that. Okay, so that's just something to note. That means our answer is going to be negative. We got to keep that in mind. Okay, so the probability of being less than Z is 0.16. But then again, we can look at the left-hand side and right-hand side, the combined left and right side gives a probability of 0.16 plus 0.16. So in other words, we're going to do that mirror image idea again. And that's equal to 0.32. So the probability of being between Z and negative Z is 1 minus 0.32. And what is that? Yeah, 0.68. Why is that good? Yeah, that means negative 1 and 1. And then I told you that we need to think about it as kind of towards the beginning of this question, is Z is negative. So the value of Z is negative 1. Any questions on figuring this out? Okay, now this is a fun one. If Z is 1.3, find its Z score. Do you remember the Z score definition? We had a definition of the Z score. It was a little equation. You all remember what the equation for the Z score was? That was chapter 2. So it was a little while ago, but not that long ago, just a few weeks ago. So what's the formula for the Z score? I'll see you all jumping in. That was an important one. It was X minus mu over sigma. So now we just figure this out. That's going to be equal to X is going to be the Z, which is 1.3. What's mu? For the standard normal distribution, what is mu? Yeah, 0. Divided by sigma. What was sigma? What was sigma? remember? Very easy, that was a hint. Standard normal distribution has the easiest mu and sigma that you can have. I'll remember 1. So the standard normal distribution has mean 0, standard deviation 1. That's the definition. All right, you shouldn't need a calculator for this. What is 1.3 minus 0 divided by 1? 1.3. Okay, and there's the z-score. This is not a coincidence that it's what we started with. Nothing changed. And that's actually why when you have a standard normal distribution, everyone uses the letter z for it, because it is its own z-score. That kind of cool? All right, ready for some other examples? Okay, suppose that x follows a normal distribution with mean 114 and standard deviation 23. Okay, and the way you write that is x tilde n 114 comma 23, which means x tilde n means x has a normal distribution. 114 is the mean, so mean 114, 23 is the standard deviation, so with standard deviation 23. So the first question is find the probability that x is between 100 and 120. Okay. I will let you know that if you try to do this by hand, and let's say I gave you 20 hours to do it, no computer, just all you got is pencil and paper, as much as you want. 20 hours, you still won't be able to do it. Just to give you an idea, this can't be done by hand. Okay, the ones I showed you, those were like very special because they hit that special, standard normal distribution. It was 1 or 2 or 3 just for z. But now we just have these general numbers and you're not going to be able to do it by hand. So what do you think you're going to have to do to find this probability? What's your thoughts? So to find the probability, what do you think you're going to have to do? Yeah, we're going to use a calculator. So which calculator do you think we're going to need? I tried to make it really obvious, and I also did it in the order at which we do things in this class. So where are we? What calculator do we have to use? Yeah, the normal probability calculator, or number 8. Okay, so the normal probability calculator, because we want a probability that involves a normal distribution. So I click on that. Okay, and it says fill in all of the values except 1 below and hit calculate. Then the last value will be given to you. So we need the low, the high, the mean, standard deviation, and p. Okay, and one of those we leave empty, the others we have to put numbers in. So do we know the low? And if we do, what is it? Yeah, the low is 100 because x is greater than 100. So I go in and type in 100. Do we know the high? Yeah, the high is 120. So I type in 120. Do we know the mean? Yep, 114 because it says mean 114. Do we know the standard deviation? Yep, it's 23 because it says standard deviation 23. Do we know the probability, the P? We don't. That's what we're trying to find out. We're trying to find what is the probability. So that's the one we leave blank. And there's always going to be one you leave blank. So I tried to make it obvious. You hit calculate. Okay. By the way, the calculator will give you more decimals than you'll ever need in your life. So you have to decide how many decimals you want. So this is one of those where make sure you read the instructions on the assignment. And if the instructions say, 4 decimal places, it's 0.3315. Okay. If the instruction don't say how many, then just do as many as you feel like that you can do without getting too tired. You can copy and paste all of these if you wanted, but let's go 4 decimal places. That's kind of standard, sometimes 2. So 0.3315 will be that probability. Any questions on coming up with this answer? All right, part B. Find the probability that X is greater than 200. Okay, we want to be greater than 200. What is the low? Yeah, that's 200. What's the high? What's the high? It's not that the sample size is just 1. We're just picking one, and that's not the high. Especially if the low is 200, the high can't be 1. A high can never be smaller than the low. Okay, it's a little tricky. Yeah, we do know, but you may not have thought about it. If you want to be greater than a number on the normal distribution, I told you this goes forever and ever and ever and ever. Does that make sense? So high is actually infinity. Okay. Unfortunately, infinity is not a number. So what we need to do is we need to trick the calculator. We'd like to put in infinity, but infinity is not a number. So what you're going to do, you're going to put a really big number in. And my recommendation is you put in 9s and 2 more 9s than the largest number of digits of everything else. So if I go 99999, then that will work. The mean was still 114 and the standard deviation was 23, and P is what we don't know. Okay, if you put 5 more 9s, you get the same answer, but 2 more 9s is enough. But it is important to look to see how many digits you got, add 2 to the number of digits, and make them 9s. So 3 digits is the most number of digits, add 2 is 5 digits, so 5 9s. 99,999, and that's close enough to infinity. And the reason why that works is if you look at how many standard deviations you are away from any of this stuff when you're 99999, then those number of standard deviations is going to be like tons of them, like over 10. And remember, I told you, as soon as you get over 3 standard deviations, probability is really low. If you're over 10 standard deviations away, it's like more than any calculator will ever be able to handle anyway, so you're fine. Any questions on that idea of putting a bunch of 9s in to make it work? Okay, I hit calculate. And there's my P equals. Okay. So the probability of being bigger than 200, you'll notice it's actually very small. And when I say I wouldn't suggest 4 decimals, I'd suggest 4 significant digits, which would be 0.000092329 rounded. So 9329. Any questions on that idea? Clear? Okay, let's do the probability that x is less than 90. It's going to be kind of similar idea. And what's the low? You want to be less than 90, what's the low? Not 1. In this case, we're going to do the same idea, but if you do 99999, that's a high number. So instead you do negative 99999. So very similar to deciding what the high is. So if the low is going to be negative infinity, then you go negative and then a bunch of 9s, 2 more 9s than the most number of digits anything has. And if we want to be, again, less than 90, what's the high? $90. That was easy. Mean and standard deviation the same. P we don't know. So I hit calculate. And you get about 0.1484. I just did 4 decimals and I rounded. Any questions at all on this example? Wanted to make sure I give you one of each of the main types. Okay, let's go some more. Let's find the probability that x is greater than 105, given x is less than 125. Okay, what does this problem look like? What are we going to have to use? Any ideas? Okay, we're going to use a formula that came from chapter 3. That was that given formula. And that said the probability of A given B is equal to the probability of A and B divided by the probability of B. Okay, you may not remember that formula, but it happened in chapter 3. So what we need to do is we're going to go and let me make it look like an equation. And it's going to be a fraction. So we're going to have the probability that x is greater than 105 and x is less than 125. That's the same thing as x is between 105 and 125. That was the probability of A and B, and then we divide by the probability of B, or the probability that x is less than 125. Have I lost you on that? That little equation that was a given equation. Any excuse to review old chapters is a good excuse. This is an excuse to review chapter 3. Okay, so we need to find the probability that x is between 105 and 125. That's calculator. So the low is 105, the high is 125. Same mean and standard deviation, we modify probability. I hit calculate. And I'll do 4 decimals, 0.3360. Any questions? Divided by the probability that we're less than 125. So now the low is going to be negative a bunch of 9s. And then 125, 114.23. And we need to find that probability. Double check. Yeah. And I get 0.6838. And we can pop that in the calculator. 3360.6838. That was 0.3360. Divided by, that was 0.6838. And I get 0.4914. Any questions on that example? Okay, so the next example, okay, and maybe I should have like given you a heads up when we started. Today's all about doing lots of examples. Okay, there's not a lot of concepts, but there's a lot of different types of examples you can have. The next example is find the IQR. Remember what IQR means? Something you'll have to do in your project, by the way. Yeah, interquartile range. I'll give you range. Interquartile range. Okay. And what is the interquartile range? Yeah, Q3 minus Q1. What does it mean to say Q3? It means 70, there's a 75% probability of being less than that value. So now I go to my calculator. Okay. What's the low if I say there's a 75% probability of being less than that value? Thoughts? We're saying less than a value. What's the smallest it could be to be less than a certain value? 0, but not quite. You can go lower. -1 is still less than a value, for example. Yeah, -9999. I'm going to go 5 nines instead. Because we have 3-digit numbers, it's always better to do 2 more nines. What's the high? The high. Okay, it's not 75. The value is not 75. Okay, this is a trick question because we don't know the high. That's what we want. The high is Q3. That's what we're trying to find, which means that's the one we're supposed to leave blank. Any questions on that idea? Q3 is a value of X. It's not a probability. So the high is that value of X we don't know. That's what we leave blank. Mean and standard deviation is the same for this example. What's P? Yeah, 0.75. And then if I calculate, I get 129.51, good enough for me. Any questions on that? Okay, now we need to subtract Q1. Okay, what does Q1 mean? Remember, yeah, that means 25% is less than that value. So what's the low? Yep, still negative 99999. What's the high? Yeah, the high is we don't know. So we leave it blank because we're trying to find that out. The mean and standard deviation were in the same problem, so that hasn't changed. And what's the p this time? 0.25. And I hit calculate and get 98.49. And I can drop that in the calculator. Whoops, not what I wanted. There we go. That's what I want. And you get 31.02. And that's what the IQR is, which is the range of the from Q1 to Q3. Any questions on this idea? Okay, so here's the next one. Okay, I used to not do this one, and then everyone had trouble in the homework, so I decided I better put this one in. Okay, the middle 84% of the data is between what two values? Okay, so that one's going to take some thought. We need two numbers, not one number. And there's two unknowns. Okay, and the calculator, you can't leave two things blank. Is that clear so far? Okay, even though we don't have a standard normal distribution, you can still kind of look at the picture I'm going to show you. So we're going to have the middle 84% is between some numbers. We don't know the numbers. We know that'll be 84% in the middle. But what we're going to do now is we're going to do kind of what we did at the beginning today. That is saying if the middle 84% is between two numbers, what percent is outside those numbers? What percent are on the tails? So if the middle 84% is in between them, what percent is outside? And the hint is you're either inside or outside. I think your thinking was completely right, but your calculation's wrong. If the middle 84% is between them, then 100% minus 84% will be outside. 100% minus 84% is 16%. Is that clear? Okay, so 16% will be the two tails. Just like what we did before, how about just the left tail? What percent will be the left tail? If 16% of the two tails, what percent is the left tail? Yeah, 8% for the left tail. So I can let's write this down. 8% is the left tail. And that's very similar to what we just did when we found the Q3 and Q1, but that was 75% and 25%. Now we're doing 8%. So now I can go to the calculator. Still gonna have negative 99999. We don't know the high. Mean and standard deviation is the same. And now P is 0.08. Any questions? And I hit calculate. And I get 81.68. So the left number is 81.68. Any questions on that? Okay, if 8% is below the left tail, what percent will be below the right tail? No, it's going to be a big percent below the right tail. If 8% is below the left, what percent is below the right? They'll be 8% above the right, but what percent is below the right? It's 100% minus 8%. By symmetry, will be below the right tail. And 100% minus 8% is 92%. So now we're going to do the same idea. Still going to have negative 99999. We don't know the high. Mean standard deviation is the same, but now it's 92%, 0.92. And I hit calculate. And I get 146.32. Will be the right number. Any questions? Anyone lost on what we just did? Any questions? Okay. You could do 8% above, but then you're gonna have to change like the unknown will be the low and the high will be positive 99999. You'll get the same answer. Okay. If we want to find the z-score for the value of x equals 117. Okay. Notice now it's x. It won't be the same as 117. It won't be 117. But what we can do is we can use the formula. So z, if you remember the equation, will be x minus mu over sigma. X is 117. Minus the mean. Remember the mean was 114. And the standard deviation was 23, as it told us. And we just plug it in. 117 minus 114. I'm just going to do that in my head. That's 3. 3 over 23. I don't want to do that in my head. Let's put this in. And you get 0.1304. Any questions at all on that example? That one actually doesn't even have anything fancy. That one you could have done a couple weeks ago. All right, ready for a real life example? All right. So suppose at the time until you or your wife, if you are male, by the way, give birth. Okay, so you're pregnant right now. Is normally distributed with mean 140 days and standard deviation 7 days. By the way, this is something you should all know. If I tell you the time at which it's going to be before you give birth, the mean is 140 days. How do you say that in words that like the whole world could understand? Average is actually that's not usually what they use for pregnancy, for being pregnant. Another word for it? So everyone uses, if any of you have been pregnant, then you know. You should know. What's the question people ask you if you're pregnant? Don't see it. When are you expecting? Hopefully you've heard that before. That's like standard. That's not some mathy thing. Yeah, when are you expecting? You've heard that before? Yeah, or when's your due date? Okay, that's another word. When's your due date? Okay, when are you expecting? When's your due date? That's the mean. Any questions on that? The standard deviation, it used to be 7 days, This is not a math question. Do you know why it's not 7 days anymore? It is. It's not a math question. Okay, it's a medical question. It's of C-sections. They don't let you go very far after your due date now. They just pull the baby out nowadays. So there's C-sections, so it's actually usually a little closer to your due date. But so we're going to pretend that you're not going to have a C-section. You're just going to have natural birth. Okay. So we can write out the distribution. We can say X tilde N because we have a normal distribution. 140 is the mean, 7 is the standard deviation. Let me do this. Okay, your boss has just scheduled you or your wife, okay, for a business trip to Africa. Okay, are you happy about that, by the way? You're pregnant. Or your wife is pregnant and she's going to go. Think it's a good idea to go out to some place in Africa for work and you're pregnant? What do you think? Okay, you're going to leave today, you're going to return in 135 days from now. Let's fix this. Okay, find the probability that your baby will be born in Africa. Any questions on the question? Okay, this is important because you're going to have to make a decision whether this is like a reasonable request from your boss or not. If it's like almost no chance of baby being born in Africa, you say, okay, I'll go. But if the baby's like almost certainly going to be born in Africa, you may not want that. Okay, especially if you want your baby to be president of the United States someday, because got to be born in America to be president of the United States. Don't know if you know that, but that's in the Constitution. Okay, so how do we find this probability? Any thoughts? What are we going to have to do? Okay, we have to, right there, N, we're going to use the normal probability calculator. We're going to go to here. By the way, if I hit refresh, it clears everything out. Then I have to remember, then I have to worry about erasing all the rest of the stuff. What's the low for it to be born in Africa? Remember, you're leaving today. What's the low? Zero. Yeah, because we're leaving now. What's the high for it to be born in Africa? Read the question. 135, because that's when you're returning back to the United States. So 135 will be the high. The mean is given. That's 140. And the standard deviation was 7. Probability is what we don't know, so we leave that blank and hit calculate. And there's about a 24% chance. By the way, do you think that's okay? Would you be okay with that? Yeah. Having a 24% chance? Let's say you're going to a rural
That seems
place
a
in
bit
Africa
risky.
that doesn't have doctors or anything like that. What's that?
I think that seems a bit too risky.
I think so too. I think so too. Just let you know, especially in rural Africa, there is no good medical stuff. If there's any problems, your baby might like really be dying. Where in America, they have that much better chance of helping the baby. And there's that whole issue of the, not being president, things like that. Okay. So part B is you decide it's too risky. Sounds like it's too risky. All right. I'm changing the state. All right, you decided it's too risky. Okay. You want to negotiate with the boss. Okay, that's how work works. And you want to ensure that there's no more than a 1% chance that the baby will be born in Africa. Okay, if there's less than a 1% chance, you're like, well, that might be all right. I don't want to lose my job. So there's a very small chance, might want to go for it. Does that make sense? What day should you ask to be the return date? Any questions on that? All right, if we go to the calculator, what's the unknown this time?
The high.
The high, so that's the one I leave blank. The low is still 0 because you're gonna have to leave today. High, we don't know. The mean, still 140, standard deviation still 7. What's P?
Be 0.001, right?
0.01.
Oh, just 0.1. Okay.
Yeah, 1% is 0.01. 0.001 would be 1/10 of a percent. And I calculate. And what this says is that if you return in, I'm going to say 100, you're going to negotiate. So let's say 123 days, because 124 days will be a little higher than 1%. 123 days will be a little lower, and that's what we want. So ask to return on day or in 123 days. I think that's 123. Yeah. Any questions on this example? Okay. A big part of statistics is decision making, by the way. I don't know if you realize that. That's a huge part of statistics is that you look at the data, you look at probabilities, and based on that, you make a decision. Okay. Any questions on that? Okay, let's look at a different one. Now it's 132 days later. The baby still has not been born. Okay. Okay. And by the way, remember, you were doing 140, 138. I mean, you're going to be showing big time. You're going to be huge, right? Or your wife is going to be huge. But you're not far from the due date. Find the probability the baby will be born within the next 24 hours. Any questions on the question? Okay, this is the probability. Okay, 24 hours from day 138 is day 139, right? So that means the probability that 138 is less than X is less than 139, given that X is greater than 138. Because it hasn't been born yet. Do you see that? Any questions on this? All right. So now we go ahead and we use that just like we did before a little earlier when we had a given problem. And we used the rule of given that said the probability of A given B is the probability of A and B divided by the probability of B. Okay, if it's between 138 and 139 and it's greater than 138, that's actually the same thing as saying it's between 138 and 139. Is that clear to everyone? If I tell you that I'm greater than 40 years old and I'm between 40 years old and 70 years old, I might have just told you I'm between 40 and 70. You see? So same idea. So probability that 138 less than x is less than 139 divided by probability that x is greater than 138. And sorry, this is small, I'll make it bigger. Now you can see it, hopefully. And then we just do it. So that's going to be equal to, we're going to have a fraction. We want between 138 and 139. So I'm going to go to 138 and 139. I want the probability. That's the we don't know. So I calculate and I get 0.05565. And the probability that x is greater than 138, that low will be 138, but now the high will be a bunch of nines. You can always do extra nines. So I just held 9, let it go. And that probability be 0.61245 or 0.6125. Let's go 4, 5. And now we just do it. We can go scientific calculator, do the fraction, 0.05565 divided by 0.61245. And you get about a 9% chance that the baby will be born in the next 24 hours. Any questions at all on this example? Okay, let's do one more example. Kind of a fun one. You're probably all hungry. And suppose that the amount of ice cream that you sell, so you got an ice cream sales place, okay, is normally distributed. And the mean is 950 ounces and the standard deviation is 120 ounces. Okay. Find the probability that on a randomly selected day, you will sell between 900 and 1,000 ounces of ice cream. One thing I always like to do is I'll write X, X, and then tilde, and then N, and then 950, comma, 120. That's how you write the distribution. And you are required to know how to write the distribution. And that's how you write it in symbols. Okay, so we want to find the probability. So we want to sell between 900 and 1,000. So I'm going to refresh. Low is 900. The high is 1,000. The mean was 950. The standard deviation was 120. Yep. And I calculate. 0.3231, 32% or so chance. Any questions so far? Okay, so part B. All right, in the morning, you took stock of your supplies and noticed you have 1,100 ounces of ice cream in your store. Okay. What's the probability going to run out by the end of the day? Okay. Running out's bad, by the way. If you own a store and you run out, then the customers are going to come and you're going to have to say, sorry, we don't have any ice cream. They're going to be mad. So that's a bad thing. You want to find out that probability. You want to make sure there's not a very big chance. So in this case, we have 1,100 ounces. What's the low now to run out? What's the low? Not zero. If you have, if 0 people come to want ice cream, you're not going to run out of ice cream. Does that make sense? What's the smallest number of, purchases of ice cream will there be to run out? Maybe I'll go back to the screen so you can see. What's the smallest number, the smallest amount of ice cream for customers to come and want, and you end up running out, and you have none left? Not a trick question. It's easy. It's not 0 though. Let's see y'all jumping in. 1,100. If you have 1,100 ounces of ice cream, and then 1,100 ounces of ice cream gets bought, you don't have any ice cream left. Is that clear? So my low is going to be 1,100. What's the high? What's the high to run out of ice cream? Thoughts? What's the highest amount of ice cream that people could order so that you run out? 1,100 is the lowest amount. With 1,101, you'd ran out. If people wanted 1,101 ounces, you ran out. What's the most amount? Yeah, infinity. So notice now there's 4 digits. So I'm going to go 9999 and then add 2 more nines. So 6 nines. Any questions on that? The mean was 950, standard deviation is 120. That doesn't change. Probability is what we want. And hit calculate. So there's around 10.56% chance of running out. Okay, and if you manage an ice cream store and 10% over 10% of the time you run out, you're going to get a bad reputation. Okay, people are going to look online, they're going to see all the reviews saying this place sucks, they didn't even have ice cream and I wanted it. Okay, so let's suppose instead of a 10% chance, or let's say almost a 90 or more than almost a 90% chance of not running out, let's suppose you want to be 99% certain you're not going to run out of ice cream. How much do you need to have in stock at the beginning of the day? So if you want to be 99% certain that you will not run out of ice cream, how much do you need to make sure you've got? Any questions on that idea? Okay, so now the probability is 0.99 that you won't run out. What's the lowest amount of ice cream asked to not run out? This is easy. What's the lowest amount of ice cream to not run out? Let's see, I'll jump it in. Okay, it's 0. Basically, if no one comes to your store to get ice cream, you won't run out. Is that clear? That's 0. The highest is what we want to find out. So that's what I hit calculate. So I have 1,229.1617. So keep ounces. So 1,229.1617 ounces of ice cream in stock at the beginning of the day. Any questions on kind of making business decisions based on the normal distribution? Okay, I want to go to the next thing. What haven't I shown you yet? The secret word. The secret word is unimodal, because the normal distribution is unimodal. It only has one bump. Okay, it's the highest. It only has one highest spot. So it is a unimodal distribution. So make sure you write down unimodal, because that's the secret word of the day is unimodal. I always try to make it relevant, but probably you wouldn't guess it, kind of thing. So that's the secret word. And I want to let you know something about the normal distribution. These are, probably not truly normal distribution. The first one used to be, but isn't anymore. The second one, probably not perfectly normal. It turns out the big application of normal distribution comes next week. And that says that whenever you do a survey, that there's a certain distribution that you care about, and we'll talk about what that distribution is next week, that is always approximately normal distribution, as long as you have a big enough sample size. So that's where the normal distribution is so important, is that for doing surveys, or, and surveys could just be like measurements of a bunch of things, and looking at the average, for example, or looking at the proportion of people said yes, it turns out that that is going to have an approximately normal distribution. And that's what it's all about. And we're going to be using that for pretty much the rest of the class. So the normal distribution is a biggie, but we're not quite there yet to see why. Okay. By the way, where have you seen something that looks like the normal distribution besides a bell? If you live in Tahoe or you live by the ocean, you've all seen it. You've probably all seen it anyway. Where have you seen what looks like a normal distribution? Don't live in Tahoe, but you've probably been to the beach, or maybe you live in, I don't know, Kansas City, and you've never been to the beach. I don't mean Tahoe's beach. Okay, sand. If you just drop a bucket of sand, or just look at the shape of sand, it's actually normally distributed. Okay, Okay, in a three-dimensional form, but if you cut it as a slice, you get a normal distribution. Okay, so the height of sand particles is normally distributed. And there's a reason for that, but to really fully understand it, you need to take an advanced physics class, not statistics. Just let you know that. But normal distribution is a biggie, it's huge. And we're going to talk about it next week and why it's so important. So what I'm going to do now is I'm going to stop the recording, and I'm also going to stop the share. So that, and then I can always answer questions. And again, you could always come to office hours, which are online. Also in my office, which has a new number, 8218. And so let me stop the recording.